Hello, so today we are going to do this Leetcode April challenge, kth smallest element in a BST. So we have a root of binary search tree and an integer k, and we want to return the kth smallest value. One indexed of all the values of the nodes in the tree. Okay. Well, the first very simple solution is to just do an order traversal and pick the kth element from the list. We can do that, and then after that we can try to do it just without an extra list. So in order again, get a node, and then we want to call it. So node dot left, node dot right, and then here we get we can return this. Plus the node value. In order traversal will give us a sorted list, and so we need to have our base case here, and the values are equal to the in order called on the root. Okay, and now we need to get the kth element. So what we do is values k, but since it's one indexed and the array is 0 indexed, we need to do this. So return that. I think this should be it. Okay, if we use more test cases. Okay, if we follow, if the BST is modified often, we can do a certain delete operation to find the kth smallest element frequently. How would you optimize? Okay, we'll see how we can do this follow-up, but let's submit. Okay, so that passes. Now let's try to do it with the in order in place. So what I will do here is this, and this, and then we'll have self.kth equal to 0, and then we can return it. But we call in order, and then node, and then here we need to count where we are, and then here we need to do I plus 1. Actually, so this is I, instead, and so self dot. Okay, so I'm trying to have a counter, so self dot count. You need maybe both kth. And then we call this, and then here we need to increment our counter. And need to check if is equal to k, then we need to set root, yeah. Yeah, we don't need I. Okay, so if we submit. Okay, so that passes. But can we reduce these? Maybe we can try to return, just have the in order stop here. Else do this, but otherwise here return the node. Oh, did I return the value before instead of the node itself? Was that accepted? Okay, so let's try to do this with a iterative approach instead of the recursive approach that we had earlier. So I would need a stack, right? and then I will need somewhere to point the current node. Okay. And now, while either I have something in the stack or I'm still traversing, then I will go to the far left or to the leftmost element. And so we will do while current. We are going to do current equal to current.left. But before that, we want to append to the stack so that we can pop the leftmost one. We are going to append current. And now we do the visit. So here we visit the node. And then here we go right. Okay, and so to visit the node, we need to pop it from the stack. So that, and then we do something here. Now to go right, we just do current.right. Okay, and now we need something to track if we reached I. So here I plus 1. We need to do if I equal to k minus 1. And this here is where we return the value. And that's pretty much it, I think. Okay, let's use other examples. I'll submit. And that passes test cases. Okay, so with this, actually it's a lot better because we are using just one index, no class variables, and we are passing. Yeah, I think this is really good. It's open, and it's the number of nodes. Sorry. Okay, so I think another slight thing we can do here is get rid of this I and just decrement k. So we can decrement it, and then here check if it's equal to 0, we can return. And that way we don't need this. And this way also, yeah, we need to decrement after the end, and that should work as well. This is of course if. Okay, now so k is one indexed, so we need to decrement before. Okay, this should work. And it does. Okay, cool. Yeah, I think this is pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.